Welcome back. Class number 12 of our course, SFD and BMD. See, today's class and next class or maybe one more class will be very, very critical for our SF and BM calculation later. Reason, all the important concepts or problems you are going to face there for calculation purpose, especially when you have to consider UDL or UVL, that all will be covered very clearly in these classes. Now see, first, in the previous class, that is class number 10, very briefly I told different types of loads. That was just introduction. It was not systematic. On that day, some randomly I explained. I had not taken care to write all systematically because that was introduction. But previous class, class number 11, very, very important, because that class I told how to locate CG for rectangle, triangle and trapezium. In case of triangle, I told right angle triangle, isosceles triangle and also general triangle. And also I told about area. Of course, area there is no problem, I know it. But always you require area and CG location later when you consider UDL or UVL or in general when you consider distributed load. So now I start systematically loading. Types of loads. This is systematic now. Types of loads. See, in types of loads, there are two types of loads. That's all. I'll put here now. One, concentrated load. Concentrated load or also called as point load. Point load. That is load acting through a point. Now, a little clarification I'll give for this load little further. Second one is, I'll tell if you want, no numbering, distributed load. Distributed load. This is concentrated load or point load. To save time in future, I will not pronounce every time concentrated load. I will tell easily point load. Distributed load. Point load means load is acting through a point. Distributed load means load is spread or loading is spread over some length. Our course we require lengthwise, but it can be area wise also. That comes for pressure or when you get the pressure below the footing or when you consider loading on a slab in RCC hall, then you consider load per unit area there. Beams all we consider load per unit length. So this is distributed load. Now see, in distributed load there are two types. Two types. One is uniformly distributed load. Uniformly distributed load. Distributed load. Short form, it is very popular. We call it UDL. Next time onwards, every class, we cannot keep on telling uniformly distributed load, simply UDL. Then, other one is uniformly varying load. Uniformly varying load. Varying load. And in our class, we consider linear variation. Linear variation. Now, there are cases of uniformly varying load where variation is not linear. It can be parabolic or higher order or based on some trigonometric function. That all not required for us. So when I tell there are two types are there, it is actually not two types. You can go for non-uniform variation. But our course point of view, we are considering uniformly varying load, linear variation. Now, in case of uniformly varying load, we will have further subdivision. See, further subdivision. One, uniformly varying load Here also uniformly varying load. 1 minute now, before going further. Uniformly distributed load is always represented by a rectangle. See, like this. This I will explain once again. You have to put close arrows. That means you can see here, uniform means constant intensity. This is actually very popularly, or usually people don't like this way. Easy to understand or write, see, this way. Both are same. It is throughout popular. So this is uniformly distributed load, UDL. We represent by a rectangle, but as we go further and further, we will write like this. Okay, now, or you can write, remember, distributed load is always represented by a diagram. If the diagram is a rectangle, you can see here where base will be loaded length, height will be intensity of load. What is intensity? I will tell little later now. Base will be loaded length, height will be intensity of load. Therefore, this is what here. This is a loaded length here. This is intensity. Here, loaded length you can see. Intensity we will write little later. Now, uniformly varying load. So once again, distributed load. So again represented by a diagram. Now, uniformly varying load, two types are there. One, UVL, two types for our course. UVL represented by a triangle. I will put triangle this way in future to save time. Represented by a triangle. This is UVL, furthermore, UVL represented by a trapezium. Trapezium. See. Now, roughly I will write here. Here, see, it can be like this. Represented by a right angle triangle, or it can be, see, represented by an isosceles triangle of both equal. These all I explained last time, but I have not told about the variation, about the intensity. I told only the diagram. Or it can be a random triangle. See, random triangle. I will tell you, explain this one. Okay. These are UVL represented by a triangle. UVL represented by a trapezium is like this. This is UVL represented by a trapezium. So, first remember, concentrated load, we simply see, that's all. It is passing through a point. This is how you represent concentrated load. Distributed load, you always represent by a diagram. And where the base is loaded length and height is intensity. If intensity is constant, that is throughout the loaded length, if intensity is same, then it becomes rectangle, which you usually write like this. Then, if the intensity varies along the loaded length, we are considering only linear variation. Maybe in the end of the course, I may consider parabolic variation or variation where trigonometric functions are involved. That in the end of the course, I will give special note at that time. Okay, now, UVL, uniformly varying load with linear variation, two types. UVL represented by a triangle or trapezium. Here, see, here, intensity varies from 0 at one end to maximum at other end. Here, intensity is 0 at both ends of the loaded length, which linearly increases to maximum at the center of the loaded length. Here, once again, it is 0 at the ends of the loaded length. Again, linearly increases to maximum at any point in between. Need not be center, any point. Now, uniformly varying load represented by a trapezium. Here, intensity is minimum at one end, maximum at other end. Never by heart left side minimum, right side maximum like that. See, it can be or both are okay. This also will do. See, as I told, this course I am not going to hurry. I will take my own time explaining all the concept in systematic order. Therefore, you should have you should have full patience to understand all the basic concept and to get thorough grip on the subject. See, now I can tell what? Uniformly varying load where intensity is minimum at the left end, which linearly increases as you go to right side and maximum at the right end. Or here, it is minimum, intensity is minimum at the left end. Sorry, maximum at the left end, and which keeps on decreasing as you go that side. When you go right end, it becomes minimum. Actually, see, here you can also read from this side. Then somebody will tell maximum at right end linearly reduces to minimum at left end. Here, if I start from this side, minimum at the right end and linearly increases to maximum at left end. So that's why left and right, those things all you should not by heart. One end, other end. That way you have to remember. Now, before we proceed further, in this case, see, this is point load, I told, concentrated load or point load which will act through a point. Now, I will give lot of clarification for this point load. Not now. As we reach our SFD BMD, then somebody will ask, then what you are doing now? We are doing all preparation for that one. Now, when we start shearing force and bending moment diagram, after one or two examples are over, then in a class, I will tell the most powerful concept. That is, I already told you earlier, I think, in case of point load, see, I'll tell you once again now, somewhere here I'll write. So just write, time being, you believe me. If this is a beam with this point load, shearing force diagram will be like this. It will be like this. Okay, now, suppose I call point A, point B, point C. Then, from A, suppose this is 60, this is 40, just imagine. If you ask shearing force, how is the variation or explain, majority of the people, how they will explain is, they will tell, suppose you put sign also, okay, put sign also. Shearing force is plus 60 from between A and C. Shear force is minus 40 between B and C. Or somebody will tell, shear force is plus 60 at A, which is constant up to the point C. Then suddenly it changes from plus 60 to minus 40, then remains constant at minus 40 for remaining length. Or suppose you ask them, what is the shearing force at A? People who know good concept will tell 60, maybe kilonewton. Okay, done, kilonewton. 60 kilonewton. I have seen people telling shearing force at A to left side is 0. Funny way of telling. To left side of A, so many people they tell 0. I am wondering why they tell left side of A. First of all, left side of A, there is nothing. There is nothing. Beam starts at A. So at the extreme end, for shear force, there is a concept. Very, very important concept, I will tell. Now, I usually ask the question, what is the shear force at C? I ask the question, I am asking that question from past 37, 38 years. Nobody is able to give correct answer. Some randomly they will answer. They will tell shear force just to left of C is 60, just to right of C is 40, minus 40. But I will ask, I do not want just to left and just to right. I want what is the shear force at C. Majority will tell no. Shear force, it is a discontinuous function. There is shear force at C is not defined. They will tell not defined. Again, no, I don't know this harsh word actually. Again, no, not correct. Not defined. Because they will tell some words they will use, continuity, etc., etc. Nothing like that. There is a beautiful concept for this one. I will convince you what is the shearing force at C, and one more thing is coming there. Bending moment will be maximum where shear force is 0. Actually, bending moment will be either maximum or minimum. Okay. It is in the local region where shear force is 0 is derived expression. But in case of point load, people will tell it is maximum, not in case of UDL or UVL, where shear force is 0, in case of point load, where shearing force diagram crosses the baseline. I also will tell that way later, but I will tell correct principle. Technically, it is for 0 only. So that also I will explain. And I will convince you, not only you, everybody who are not knowing this concept, later it will be a special class. The numbering will not be this way. As I go class number 12, 13, 14, 15 like that, I will put without number. I will write special concept. That day I will explain point load. So time being, I am not explaining much about point load because I want to hold the explanation to that class. That way, later, so many finer points which are misunderstood or misquoted, I will clear one by one as the time comes. Okay, now start. Point load I will come later. Types of load I told what? Distributed load, either UDL or UVL. UVL by a triangle or trapezium, different types of triangle I explained here. Now, I will now start one by one, and before one by one going, I will tell one thing. We are going to consider now all the standard cases of which one? Point load, UDL and UVL. We will decide here how to find the magnitude of the load. If it is point load, you will be knowing later, whatever you write here itself is magnitude, or a point load or concentrated load is defined by the magnitude only. Line of action, you can see here. Point of application, you can see here. In case of distributed load, load is spread, then we want what is the total load. Total load need not be for entire length. I already told you. Total load for whatever length you want to consider. See, I told already, if I want somewhere here, if I want some calculation here, and if I look this side, then I require total load here. But if I want some calculation here, maybe shearing force or bending moment, then you have to look only one side. Then the total load will not be this total load. It will be only from that point or section up to this side. If I look this side, it will be total load only for this much portion. Or here, total load only for that much portion or loaded length. That all I will explain. Along with that one, I will make full clear how to consider moment. See, at present moment, but later moment term will not be used. It will be replaced by the powerful term, that is bending moment. Again, one more concept, misquoted everywhere. Moment, bending moment, they mix up. I will separate it. I will convince you moment is different, bending moment is different. This I told in the demo, in the class number 1 I told briefly, remember. Class number 1 I told briefly, one of them is direction based, other is nature based. This all will come one by one. Okay, now I will start one by one now in order. Maybe class number 12, I want to thoroughly cover everything, not randomly do something, very thoroughly I want to cover. So maybe today I will cover point load and UDL. Next, I will cover uniformly varying load in another class. Then one more class required where I will give special coverage. That is, how to proceed or how to calculate anything means what? Either load or moment when you are not considering the full loaded length, when you are considering only partial loaded length. That one more. So I think I require 3 classes for complete coverage of all types of loads where distributed load, either UDL or UVL, either UVL either by represented by triangle or by trapezium, how to find total load and how to find the line of, how to locate the line of action, then how to find moment either for full loaded length or for partial loaded length. That will be thoroughly covered. Okay, now I'll start one by one. Okay, we'll start now. I already written because to save time. Concentrated load or point load. See, this is standard case. This is numerical part. Of course, for point load, people will not need this much explanation. But I always explain everything. I don't take chances. See, this is bookwork type. W. See, I am writing W, or some people they call P. No problem. Any symbol, or even F also I have seen people using. Or sometimes people use the word Q, capital Q. That is, symbol is your problem. In my class, what I do is, for point load, I take capital W. And for UDL or UVL, where intensity comes, I take small w. So, to understand clearly, when I write capital W, in my class, if no other data given, it means point load. And when I write small w, it means intensity of load. Okay, now start. W. This is point load acts through point B. So what I require is, or what you require is, 1. Magnitude of the load. A point load is defined by its magnitude only, or for a point load, what you are seeing itself is the load. Remember, I already told it earlier, for point load, what you are seeing there itself is the load. Therefore, directly, magnitude of the load equal to W. That's all. Direction, see here, vertically down. It can be later right side or upward or left side or incline. That will come later if requirement is there. Here, as per this sketch, vertically down. Line of action. See, later I am putting LOA to save time. LOA later. Line of action of the load passes through the point B. I am not written because I want to write in front of you only. Okay, then. So, here, magnitude of the load is W. As you are seeing here, this W itself is the magnitude and the line of action passes through B. Now, as I told earlier, do not tell W kilonewton, W Newton, or later, see, some distance, L will come. L in meter, centimeter, do not tell those things. You tell simply some symbol for magnitude and some symbol for length. When it is numerical, yes, correct. There you use unit. There you should tell kilonewton, Newton, or meter, millimeter. There you have to use it. For numerical, for bookwork or standard case, never consider unit. It is actually very funny to write beam of span L meter. So many people are writing that way. And loaded by UDL of W kilonewton per meter, or point load of W kilonewton or P kilonewton. Why? Is it valid only for kilonewton? It is. I already given an example last time. So don't write that way. W is the magnitude in my class, passes through B. Now the most powerful why I am taking these 3 classes here is for moment. See, this is thoroughly to be understood. See, little space problem there. I will shift it here. Okay, what to do? I wrote little closer. Okay, leave it. Now, moment of that load W about different points I want. Now, already I explained moment very clearly earlier, maybe 3-4 classes. So I should not explain once again, but my nature is not that way. Whenever some concept will come, even if told earlier, sometime I tell once again. Okay, now, first remember, don't see here now. When you want moment, it is a product of, see, magnitude of the load and perpendicular distance from that point about which you want moment. 2. Line of action of the load. Now, therefore, when you want moment, I will tell it later now, in future, throughout our course, not only throughout our course, If you are continuing the structural field throughout your what? Structural, what you can tell, throughout your structural field or complete your structural career, what you have to do is, when you want moment, see, load can be like this or inclined, anything. Even if it is distributed load also, when you want moment, see, now onwards, your hand should move like this. You should consider which point you require moment. Maybe, see, I want moment about this point, or moment about this point, or maybe this point. See, now, if I want moment about this point, it is load. See how my hand is moving. Now this is permanent to make clear. Because why sometimes in case of UDL or UVL, when they multiply, see some UDL given. Just I'll tell you why I am telling. See, for example, I write here. Maybe 30 kilonewton per meter. Length is 5 meter. People will write 30 into 5. They keep quiet. Why? Why kept quiet? Sir, over. Load into distance. What is that one? 30 into 5 is not the moment. 30 into 5 is the total load. So, that is, if it is a UDL, you have to get the total load. Therefore, what you have to do is, see, when you consider 30 for 5, your hand is moving like this. See here, load is spread for 5 meter. Your hand will move like this. That is UDL of 30 kilonewton per meter for, see, 5 meter. You have to get this way. Therefore, now onwards, permanently in my class, when you want moment, I won't tell again and again now. See, you first hold the point about which you want to moment. Very important. See, if I take a point as O1, if I take this as O2 and O3, if I want moment about O1, come here. Put finger here. You need not put finger permanently. Once you get practice, okay, till you get practice. Now, load, your hand has to move like this. Either this way or whatever way, it should have a linear movement. See, load, then when you tell load, it should come this way. That means, if it is a point load, it is directly the load. If it is distributed load, it will be total load. And again remember, total load not for entire loaded length. Depending upon the requirement, it can be partial length, but it should be total load or resultant load. I will not repeat once again now. See here. Load, see the hand moving, then multiplied by. What I do is to understand thoroughly, see this multiplied. Actually, some will be laughing. What is this? No problem. I use one dot here. My students know it, dot. See, when in case I write here 30 into 5, I put a dot in the class. My student will shout, no sir, this dot is not that dot. Sir, this into is not that into. This into is what? Conversion of that intensity to total load. Now, sir, now that into will come. See? Of course, I will ask them, how you know it? Sir, this is told by you only. Okay. Told by me only. I just for fun, I will put a dot here. They will start shouting there. Sir, no, sir, no dot. That dot comes afterwards. I will tell them, see, it is not a correct concept. Somewhat crude, but not wrong. So don't make a practice of that one. Till you get the grip, you use it. So remember now, in my class, now onwards, up to some time, when I feel that now it is not required, I will stop. So till I feel, no, you have still lot of things to learn. Till the stage, I will write always this into. Then multiplied by distance. See, simple language. Distance. Now, distance means what? Last time in the class I will tell you, but some will tell in the class, he will tell again and again. Distance means perpendicular distance from the point about which you want moment to line of action of the force. So if I want moment about O1, it is load into this distance. See, if I want moment about O2, see here, load into this distance. If I want moment about this point, I already told you, load, there is no distance. Why? That point lies in the line of action of the load. Therefore, perpendicular is 0. So answer is 0. So remember, this is not for point load, permanent. It is for point load or UDL. UDL means, point load or distributed load. Distributed load means it can be UDL or UVL. UVL means it can be UVL represented by a triangle or trapezium, whatever it is. Now onwards in my class, when you want moment, see, I'll tell once again here. If I want moment about this point, see, I want hand to move like this. Load. How to get that load, I will explain. If it is point load, load is what you are seeing there. See here. Yes, W or 100. Not if it is UDL or UVL. Then this load you have to get. That is next part is coming now. Very clearly I will explain. See, load, then into, that into, I will put a dot up to some stage. Into perpendicular distance. Here I wrote only distance, not random distance. Perpendicular distance from the point about which you want moment to line of action of the load. I think it is sufficient. Then decide whether it is a clockwise moment or anti-clockwise moment. See, if your point is somewhere here, this way, see, if the load is here, this I don't have to explain. See, load into distance means, see, moment will come. It will be clockwise moment. Now, in case my point is somewhere here, see here, load is here, see now, load into distance will give anti-clockwise. But remember, if it is a reaction, upward reaction, then load into distance, see, will give clockwise. Whereas here, if I look that side, if it is an upward load, maybe reaction, then load into distance will give anti-clockwise. That you have to practice. Okay, start now. Fast. Here I told you moment about A. See, if you want moment about A, your finger should be at A. Till you get the grip. First I want load W over. Yes, W is a load only. Why magnitude? Because it is a point load. For a point load, what you are seeing itself is the load. It is defined by magnitude. Then multiplied by, see, into L1. And see, if I hold here, never remove the finger here. See, clockwise. Now, moment about C I want. So come here. Load W into from C perpendicular distance L2 anti-clockwise. So it is W into L2, what into? Moment into. This into I am calling moment into. If somebody is laughing, let him laugh. No problem. In my classroom I will tell, if somebody laughs, bring him to me, let me see how he will laugh. I am using such easy concept only for your benefit. I don't require all these things. No. I can go to very high level if I want, but I am not going. Because purpose is to teach, to make you understand. It is not the question of how much I know that counts. Of course, it counts actually to teach properly. But for a student, it does not matter what level of knowledge the teacher is having. How he teaches, and from his teaching, how much he learns, he or she learns. That is the important part. That is what counts finally. How much he is able to convince us, that counts. So, now, see, when I take moment about A, W into L1 is clockwise. I write here, clockwise. No kilonewton, no meter, nothing. Now, when I take moment about C, W into L2 is anti-clockwise. Moment about B will be 0. I already told because point B lies in line of action of the force. Okay, now this is bookwork type. See, I'll write here, bookwork type. Now immediately come to numerical. That is what I am doing. Now next class onwards, I'll write, one side I'll put UDL, bookwork type, other side I'll put numerical. That way I'll continue, so that when you solve a problem of like, sometime you get a case of what, a beam of span L subjected to UDL of W per unit length, you should know how to solve. So bookwork means, that is for bookwork purpose, I will not use unit. I will explain. Then you get, see, a beam of length 8 meter loaded by UDL of 40 kN per meter, numerical. I will make everything fully clear before we start SF and BM. We are very near, don't worry, very near to it. Start now, near. Numerical. Magnitude of the load. By looking on, you will tell 100 kilonewton. I took 100 because I don't have calculator here now. So for calculation, 100 means easy to calculate. 100 kilonewton in the bracket, direction, down, over, vertically down. Then, line of action of the load passes through the point B. And remember, sometime I will write A, B, C and A, B, C here. In the class student will tell, sir, that is not C. I told, who told you? It is my wish. Why are you mixing these two? I can write some other name here. I can write A here also. Do not by heart A, B, C like that. Also, do not by heart L1, L2. Again, don't by heart W. Remember, load and distance. See here. Magnitude of the load, 100 kilonewton down. I don't have to explain further. Line of action of the load passes through point B. Now, moment of the load about A I want. See, start. About A means, see here. Don't remove the finger till you finish now. I told already. Load, yes, you know. 100. I'll remove that one because it's obstructing me. This obstructing, I'll remove it. See. And remember now, this is moment. Because, why I am telling? Because this is direction based. Moment means clockwise, anti-clockwise. Load, downward, upward. Later for shear force, it is something else. For bending moment, something else. That's why I always insist, direction based is different, nature based is different. Okay, now, load, 100 multiplied by, which multiplied by? This way, into 2.2. 2.2 over. See, if you calculate, this will come 220 kilonewton meter. Why kilonewton meter? It is a product of force and distance. So force unit is kilonewton, distance in meter, it will come kilonewton meter, not kilonewton per meter. That also I have seen plenty of places. But I don't know why people write moment in kilonewton per meter, especially bending moment. That is called absent mind feeling. Simply kilonewton per meter. Little if you think you can make out, moment it is kilonewton meter. See here, if I take about A, 100 into 2.2 is clockwise. I will not explain again and again. Clockwise. Then, if I want moment about C, come here. 100. See, I told already. For a moment, your hand should once move this way. When your hand moves this way, that should be the load. 100. See. Multiplied by, see, that into 1.8. Equal to 180 kilonewton meter. If I take moment about C, it will be anti-clockwise, right? Anti-clockwise. This is not there. Anti-clockwise. Lastly, moment about the point B is 0. You already know it. So now, I very thoroughly explained how to find load. Actually, total load word is not there because actually later, when I go to distributed load, we will use the word total load. In case of point load, I will not repeat that load itself is total load. There is no total. So we want to know total load for point load, yes, clear. How is the direction? Yes, clear. Where is the line of action? Clear. How to find moment of that load about any point? Clear. How to decide direction? Now direction. Later nature. That one by one. So now with these examples, it should be crystal clear for everybody how to find total load or load, decide direction and locate the line of action, and also find moment for a point load. That much should be clear. Next we are going for distributed load, because see, this is very simple. Everybody, those who are viewing now, they may have little impatience. This is already known to us. No, if it is known to you, once again know it from me. Once again know it from me. I know better way of telling it. In a way so that, because I am correlating or linking this one to UDL UVL. Why I told, when I go to UDL UVL, I am correlating it, I am linking it. I will tell, see point load what I told. Some will tell, no, we did not go through it. Go through it once again. I told, go through it once again. No, we know it. You are not knowing. Once again, go through it. I will tell. I am sometime I talk little offensively also. Not that way. I am not that type of person. But offensive means when I feel hurt or offended. If someone tells, I already know, and then later they ask doubt, I get angry then. I told on that day only, everything I explained. Why not gone through? Sir, I was knowing at that time. Now you are not knowing, correct? That's why you are not knowing. Whatever I tell, go through it. It is applicable to all of you also, unless any viewer is already knowing everything. If he is already knowing everything, I don't know why he is viewing my class. Or to find mistake, that is left to them. Okay, now, I will go to other case, distributed load, UDL and UVL, that is in next class now, time over.